Thank you very much, Fridtjof, and the presenters too for the technology showcase. Maybe my mind is just a bit smaller. It doesn't have the same scientific bent, but we've had a lot of information this morning, a lot of technical information about fascinating innovations involving not just what to do, how to detect it, but how to detect munitions in the seas, but the mapping in general and how to share the incredible volumes of data that all of this generates. And one of the things that is going through my mind, how much overlap is there in all of this? It sounds like there's a great deal of competition right now to come up with the best methods for detecting and mapping and sharing the data, which of course drives innovation. And I can only hope that when the chips fall, that we end up with some really good solutions. It looks like some amazing things are in the pipeline there. So we're moving on to our next session this afternoon. Are we into the afternoon? We're getting there. Remediation solutions. I've talked to some of you during the coffee breaks and the receptions the last couple of nights, and I know that many of you are looking very much forward to this particular session. This is focusing on what to do with unexploded ordnance. I mean, that is the question. What do you do with it? Do you explode it in place? Do you try to raise it and take it on land for disposal there? Should you try to incinerate it in place or on the surface? And we've heard a bit about all of those so far. Each of these methods is not perfect. They each carries risks and costs, significant risks and costs. And it's simply easier said than done. Every old technology is, we hope, going to be superseded by something new and better, but sometimes you come to the conclusion, well, perhaps it's just better to leave it at the bottom of the sea. We heard that view yesterday in one of our sessions, because when it's so deep, what do you do when it's down there? Is it cost effective? We're going to be talking about some of that today. So we're going to look at some new technologies perhaps that are also in this session in terms of what is feasible, what is coming in the pipeline for helping us to dispose of armaments and chemical agents in the sea. Very difficult topic indeed, but we're going to get a glimpse of that as well. So without further ado, we have 4 panelists. I don't know where they are. I was hoping to see them down front, so I hope they're with us in the room. I understand we do have all 4 with us here, and that none of these gentlemen are going to be joining us remotely. My apologies in advance that we're all an all-male crowd, but I'm glad to see that we do have some representation of women on this topic in the room. So let me begin by Professor Jacek Bełdowski. We've been having some interesting conversations the last couple of days. Professor of the Institute of Oceanology at the Polish Academy of Sciences, head of laboratory there, dealing with contemporary threats to marine ecosystems. He's a coordinator of multiple international projects dealing with the impact of dumped munitions in the environment, projects that we've already heard a bit about so far. I'm sure we're going to hear a lot more. ChemSea, Modem, Diamond, or Damon, how do you say it?
Well, Diamond.
Diamond, okay. Diamond 1 and 2. So multiple projects. Yeah, feel free to have a seat. You just come up to the stage when I call your name. Terje Schmitt-Eliassen is commander of the 3rd Minesweeper Squadron of the German Navy, which is based here in Kiel. Marvelous. Please do join us on the stage if you would. Watch your step. He entered military service 26 years ago. I read in his biography, and his first assignment was on a mine hunter, apparently. Thank you very much. Guldin is also there, Chief Operating Officer of SeaTerra. He's been at the sharp edge, so to speak, of survey and clearance companies dealing with unexploded ordnance for more than 20 years. Jan Krabbenhöft is also with us, Director of the Services Division of thyssenkrupp Marine Systems. He began his career 25 years ago in the commercial shipbuilding industry. thyssenkrupp's seagoing platform for salvage and disposal of large-scale munition, which we've seen already just in an illustration, has been developed in his division, and I'm hoping we'll hear more about that today. So, just going to get our technical ducks in a row here, but perhaps we can begin with the presentations. We are going to have presentations. I'll try to be as generous as I can in terms of time. Roughly 10 minutes. If you go a little over that, no big deal. I do want to leave some time for questions, however, at the end. So without further ado, let's start at that end. Yes. Yes, sir.
Thank you. Okay, welcome everybody. So as I was introduced, I'm the coordinator of the Diamond 2 currently project, but several projects before that. And we are trying to respond actually to one of the questions which was asked today to Jens Greinert: where to start? Which munitions go first? So the title of the project was the Decision Aid for Munition Management. And basically we started with the work on chemical munitions, which are in the proper Baltic, in the Bornholm and Gotland Deep, mostly with the ChemSea project. Then we created some background for monitoring within the Modum project, which was mentioned here on the first day with NATO SPS. Then with Diamond and Diamond 2, we are going towards the categorization of risk. So the first step, of course, is to get the data. And you've heard a lot about it in this conference. So basically, you have to know where the munitions are. You have to identify what is the type and state of those munitions. Then the big question is, do they leak to environment? Do they pollute sediment, pore waters, water, biota? And then you have to know what is the impact on environment. Does it change biodiversity? Does it destroy habitats? And does it have adverse effect on marine biota, which we measure by biomarkers? So we have collected a set of methods to measure all those things. But what's more important, we have also compiled algorithms how to interpret them in a digital world. So you could actually use a software to interpret the results of those methods. And also we have interpreted the weighing mechanism to show the machine what are the importance of different factors. So regarding detection, we were using side-scan sonars and magnetometers mostly. Sometimes also multi-beam echosonders in cooperation with Geomar. This here is Koberger Heide, but we've been also using SAS on Skagerrak, where the munitions are dumped in wrecks. There is about 150,000 tons of chemical munitions there. And this data was actually too big to import it at the time. So we decided to convert it to two values. One value was the actual position of the detected object and the type, if known. And another one was the density. So we compiled the density based on GIS using buffers. So we basically used the values in which we detected the degradation products of warfare agents or explosives in the sediments. So, for example, for sulfur-based agents, it was about 50 meters where the concentration was still meaningful. For arsenic agents, about 250 meters, and also for explosives, about this range. So if the munitions were closer than those buffers, then the risk rises because there is a sympathetic adverse effect on the environment because you've got multiple sources projecting to the same area. And regarding the munition status, of course, the identification is the first step. So we've built 2 online catalogs containing different types of munitions which could be encountered in the Baltic, including also in some cases pictures of already corroded objects. So the ROV operators or the people responsible for identification will have an easier work of identifying munitions they found on the bottom. Regarding the corrosion, we performed some very brute force experiments because the existing corrosion models are disagreeing with each other a lot. I will come to that. And then regarding the actual threat of explosion, so this was the presence or absence of detonators, and the leakage. We have actually tried to monitor the leakage via landers and also via laboratory experiment with munition imitators. So regarding the corrosion, here you can see the mustard bomb KC-250 shortly after dumping, which was short on Bornholm, and the state from 2 years ago when we observed those objects on the Bornholm Deep. So as you can see, it's almost completely corroded. So the brute force experiment was just go and measure. We have approached museums to give us the actual bombs and projectiles. And they were in possession of such materials, so we got a bomb and a 105 millimeters chemical shell, empty of course. Then we cut them into little pieces and we exposed them both in sediments and in water in different Baltic dump sites. And after that we calculated how fast they corroded after retrieval. So it seems from this approach that everything which was dumped in barrels pretty much corroded some time ago, like the year 2000 or even in the 90s. The bombs will corrode right now between 2020 and 2030, whereas the artillery shells will corrode about the year 2100. So the time horizon is not so long. So when it leaks to the environment, then of course you have to know how fast and how far does it penetrate. So we used high-resolution models which were calibrated for those specific depths in the Baltic Sea. And according to those models, we've got the propagation of about 10 kilometers after losing containment, even in a period of 5 days with average currents. So regarding pollution of sediments and water, we looked at heavy metals which are associated with munitions, so arsenic and lead and mercury, which comes from munition primers, chemical warfare agents and the degradation products, and explosives. And this is just an example of the chemical warfare agents. So red dots are positive detection of either arsenicals or mustard derivatives. And as you can see, in the primary dump site in the Bornholm Deep, everything is red, more or less. But in some scattered dump sites, like unofficial dump site in Gdańsk Deep, or in a more vast dump site at the Gotland Deep, which is in the middle on the bottom, you only have some detections. So not every object which is even identified as a bomb does actively leak to sediments. So then those images you have already seen. This was done by von Thünen Institute, the impact on biota, the fish disease index. And if you average that, there is no significant difference. But on some years, you can observe that there are more adverse effects on fish in Bornholm than anywhere else. We suppose it depends on oxygen situation in the Bornholm Deep. Also, we have confirmed that arsenic-based agents are accumulating in fish liver, but also in fish flesh. So if the leakage increases, then there would be a hazard for fish consumers. At the moment, the concentrations are very low, so they are safe to eat still. But of course, this opens the avenue for future threat scenarios. So with all those methods and the algorithms which are weighing the risk and comparing the risk to other factors, we have the DSS, the Decision Support System, which was created within the project and which is hosted on the AMUCAD as one of the AMUCAD modules, and you can access it there. It's free for use. And basically, it does not calculate the risk for the entire area. It calculates risk for a single munition. So you've got the databases containing positions and identification of everything that we found. Also, all these other factors like sediment data, fish data, water data, you've got also so-called actors on the objects like the environmental variables, meaning like salinity, oxygen, temperature, they all have influence on the effect. And all this is fed into neural networks. So you can add a new munition and add the data that you personally collected, but every missing data will be collected from the existing databases if they are close enough. We've got some range limits where it can suck the data from. And then it will go to neural networks, which will make the evaluation. And this is more or less how the user interface looks. It's a bit more complicated right now, but you've got very important parameters on the bottom. You've got the ecological hazardness and the level of confidence. This roughly gives you how dangerous is the object and how sure the system is that it is dangerous. So then the report is created, and in this report you've got actions related to explosions, actions related to corrosion, and also based on the VRACA model, you've got the action related to marine users. So if the fishery is the biggest threat for this particular type of munition, then the solution could be the simple ban of fishery in this particular area, like a bottom trawling. If the military activities are the biggest threat, then this area should not be a subject of military training grants, and so on. So the system gives you such a report, including this high-resolution model, so it shows you potentially affected areas. It shows you the risk to particular risk groups, so-called protection goods, and it gives you also the missing data, so it shows you if the level of confidence is low, then it's suggesting you which studies should be performed to improve the result. But the final message it gives you is the options. It gives you several scenarios of what to do. Like scenario 0 is do nothing. The munition is not dangerous. If it can be a threat in the future, then the solution is the monitoring. If the threat depends on some human activities, then restricting those activities or including that into maritime special planning is an option. But if the risk is related to corrosion and it's the risk for the marine biota and for the ecosystem, then it will suggest the remediation. So at the moment, it will just suggest to remediate and will list a range of options like recovery and destruction, blast in place, and things like that. In future, we plan to expand the system to actually use the results of the future program Proband, which is trying to develop a model which will relate different remediation scenarios depending on the local conditions, and then it will suggest you more real solution, the most environmentally friendly. But, well, at the moment, it's maybe a bit simple system, relatively speaking, but it exists, and it can give you a tool to prioritize areas and munitions to remediate based on a real scientific knowledge. And definitely it's expandable in the future. So when the new methods begin to appear, we can easily include them in this decision support system. So we hope it will improve over time. So with that, thank you for your attention.
Terje?
for having me present the more military view on this problem. Ladies and gentlemen, to start with, I'm happy to welcome you, parts of you in my squadron this afternoon. The slideshow gives just some expressions of what we look like and what we do, and we'll go into greater detail this afternoon in the naval base. We all share the same aim, to make oceans safe, to make them safe for shipping, for humans, to preserve them as natural habitat. Unfortunately, all that is endangered by the remnants of war. The clock is ticking, and we need to find scalable solutions to counter these threats. And I guess the German Navy is more than happy to contribute, and I'm basically the one being able to do so in the moment. With his opening keynote this morning, the Chief of the German Navy stated the Navy's stake in this endeavor, and I need, at least briefly, to recur to some of his key points. It's obvious that the Navy is a frequent guest in the North Sea and the Baltic Sea, and despite having great experience in underwater operations, which we are happy to offer, we are not responsible for clearing old ammunition. It's not the purpose of the armed forces. This task is inside our territorial waters, the responsibility of our federal state, and is carried out by the so-called Kampfmittelräumdienst, the federal EOD capability. The Navy provides assistance when requested by the federal states. Closing in on this panel's lead questions, I briefly need to explain where I'm coming from and what I'm responsible for to put my squadrons, the minesweeping squadron's role, into context of the task at hand, and looking at the remnants of war. I'm, as I was introduced, the commanding officer of the 3rd and only minesweeping squadron based here in Kiel. We hold the expertise of the German armed forces when it comes to ordnance at sea. I'm command of 10 dedicated mine countermeasure units and roughly 850 personnel, and these 10 units are primarily warships, and they are designed to minimize acoustic and magnetic emissions, not to trigger mines themselves, and they are built to withstand a detonation of a mine in their vicinity. My crews are trained to operate their units within active minefields in times of crisis and war. Their primary task is to ensure safe passage to follow-on traffic through those minefields and to keep sea lines of communications open. They have to fulfill this task under enemy threat and under time constraints, because you can imagine you want to be resupplied in times of crisis. To sum it up, my units are able to operate within a minefield, and that's what their design and their sensor and effector package is focused on. Their primary task is to counter mines as fast and as efficient as possible. They do this to ensure open sea lines of communications, thus safeguarding resupply routes, freedom of navigation for military and wide shipping, and to provide operational flexibility for other naval units. Having explained my task, I'd like to highlight Admiral Schönbach's, my boss's, expectations towards me. He asks for well-trained crews, he asks for combat-ready ships at his disposal to contribute these capabilities whenever requested by politics. To achieve this, I need to ensure that the training of my crew prepares them for their primary mission. And I'm sure you've all heard the saying, train as you fight. That's exactly why we need to train them on hot ordnance, preferably to create win-win situation on historic ordnance. This is essential to finalize their training and to prepare them for their task. My crews need to do this with their tools at hand, with their tools at their disposal, and these are our mine disposal vehicles, a one-shot mine disposal ROV, and our EOD divers. Of course, and this is absolutely nothing to argue about, environmental aspects supersede this needs. Over the last years, we heavily reduced numbers of blasts, we heavily reduced the charge size, we limited those trainings to very specific times of the year, and we used every tool at our disposal to scare off marine life. And now, since more than 2 years, we totally resigned from this last part of the certification process, but at the cost of my crew's excellence and their preparedness. In parallel, we try currently with all stakeholders involved to introduce bubble curtains as protective measures, and we as a squadron just recently completed testing whether the primary effector, this one-shot ROV, can actually operate through such a curtain. because as a side effect, the bubble curtain obviously cuts off all sonar information, so you basically fly into the dark. We achieved very good results during those tests, and we are currently pursuing this solution to ensure training for my crews and other applications to the necessary level in the future. Closing this train of thought, I want to connect the dots. The primary mission and purpose of my units dictates their design and their tools. This mission, and we all hope it never comes to that, puts environmental aspects on the co-driver's seat. In times of crisis and war, we are forced to simply dispose every contact appearing to be a mine to fulfill our time-sensitive tasks. Thankfully, we're not in times of crisis and war, and during peacetime and training, environmental aspects obviously supersede, and this and driver and co-driver change seats. Nevertheless, we're not the driving momentum for remediation solutions. We are rather in the role of the happy user of all innovations which fit to our purpose. Coming to the end, the question is how we can contribute to the important mission at hand. My squadron just turned 60 last year, so the Navy and my squadron hold plenty of experience in detecting, identifying, and countering ordnance on the seabed. We have 10 specialized units with highly trained crews. We survey the seabed on a daily basis and are 24/7 part of NATO's standing MCM group. We already have, and we are constantly refining a huge database together with other nations, charting ammunition dump sites and old minefields. So we have a pretty decent picture on the seabed and know what's going on. We hold the leading expertise in Germany when it comes to countering these threats. Nevertheless, this explicitly excludes recovering old ordnance, but it includes all actions of low order and high order disposal procedures, as well as lifting or shifting ammunition with lift bags and for cases where they are in the vicinity of critical infrastructure. Finally, I think it's fair to state that we are all facing the same opponent, namely ordnance mines on the seabed. We have slightly different approaches towards this opponent based on our profession. I guess the commonalities outweigh by far, and looking at this great challenge, I guess it's worthwhile exploiting these commonalities for the benefit of the urgent task to tackle the imminent threat posed by the remnants of war. So I think we should actively seek and create situations where all stakeholders, and especially the environment, thus we all in the end benefit from each other's competences to counter this threat. And I think the Navy and my squadron is happy and eager to contribute. Thank you.
Thank you very much, Dieter. Terje, Dieter.
Yeah, good morning, ladies and gentlemen. Thanks for having me here. My name is Guldin. I'm COO from SeaTerra. And actually, we are part of the industry which is taking care already for survey and clearance for several years. So SeaTerra especially just finalized several projects within the last few years. One of them was UXO clearance on the River Oder from Stettin to Swinemünde. So we did a clearance there of about 45,000 objects, having about 2,000, 3,000 UXOs. And we've cleared them from the seafloor, but we are also actually doing UXO survey and clearance operation in the North Sea and the Baltic Sea for quite some years. And when I was invited over here, I was under the impression I have one presentation, but then I found out a few days ago I have two presentations here, so I will have a presentation tomorrow as well. And what I did is a quite smart move. I just cut my presentation into half. Yeah? So you will have the first half right now, and the second half you will have tomorrow, which actually means the kind of presentations I do is I reflect on what we've done so far, yeah, what I see from my point of view, so the perspective on UXO clearance offshore and addressing the issue of dumping areas. And tomorrow, actually, I will give a picture and a presentation about the project we recently done. It's called Minsener Oak Project, where I see that it might become a kind of a game changer because it was the first time we really used a crawler system over there on the seafloor. So it's not all about theory at this time. So there will be also a perspective of what we have done and a clear picture of what we have cleared and how we did it tomorrow. So my first slide, what you can see over here is I just reflected on the situation of technical innovations driven by wind energy or correlated to offshore wind energy. And if you look at this, yeah, you have got some periods and times. Yeah, so starting with 1950, we have the UXO, the Minesweeper boats, and in the 60s it starts also with divers, and then actually the situation remained for quite a while. Yeah, so until 2013, when we did the first UXO clearance on a wind park. Yeah, actually, there was not that much of technical innovation taking place. Yeah. So, if you look at 2013 until 2021, yeah, the airlift came in, RVs came in, working class RV came in. We had 2019 excavators with mini tools, and we have the multi-tool. And in 2021, we have the crawler system. This is all technical innovation which has been invented and actually basically paid by the companies working within the industry of UXO clearance. And nothing of these equipment or technologies or innovation has been paid by the government. It has been paid by the industry itself. Yeah. So naming companies like Baltic Tower, Eggers, like SeaTerra, like Boskalis Hirdes, they are actually the guys in place which are doing the job so far. Yeah, so UXO survey and clearance is not a fiction, it's a reality, and it takes place every day. We are able to do it, we've done it so far. So the next line you see below is installed offshore wind capacities. Yeah? And if you correlate this, yeah, so as more wind turbines have been installed, yeah, as faster the innovation stepped forward. Yeah? So what that means actually, it means that if there is actually a market, the industry is capable to go behind the market, yeah, to be innovative, yeah, to bring new technologies to the market. And unfortunately, wind industry has then been limited, so there was it went down a bit again. Yeah, but actually, what I want to show or what I want to make clear is within the context of existing market, within the safety of something can be addressed and paid, something will be paid. If we are able to be innovative, we are able to address situations. And so at the lower bottom, you see the numbers of targets which have been actually recognized or noted. So this is the number of targets which have been cleared for the year in tons. And I will come back to that later, but actually to make clear, where do we do UXO clearance? It's like, this is especially for SeaTerra, it's like 90% for offshore installation and infrastructure, 8% for survey and clearance operation, and 2% for environmental protection. So that's actually where clearance happens at the moment in Germany. So the focus on environmental protection, which comes up here, which is actually pretty new, and actually there is not really any kind of clearance operation going forward in this environmental protection sector. So all UXO clearance which takes place has something to do with infrastructure. And I think the time has to come, or the time has come, or is already here, where the focus has to change and where the environmental protection UXO clearance should really start. So on the UXO clearance projects we do so far, we have about 4 to 5 to 6% UXOs within the context of what we clear in the field. Yeah. That means actually we're not doing UXO clearance, we do a scrap metal detection, scrap metal clearance, and the UXOs is just a small part of it. Yeah, because the reason is, if you build a wind park, if you build a wind farm, you won't build it where the historical research told you there should be a dumping area. Of course, you build it outside that. So, actually, UXO detection and UXO clearance takes part where there is supposed to be no UXO. Yeah, so we are not inside the areas, we are outside the areas so far. And that's the reason why the percentage of the UXO is so small. On the Minzener Oak project I will talk about tomorrow, we had 79% of UXOs and only 3% of scrap metal. So if you start to address the dumping areas with investigation, with survey, and with clearance, there is a much higher efficiency. And the efficiency is actually what I want to talk about in that slide. Looking at the numbers from 2013 to 2020, you've got 26,912 objects. Imagine every single object would be a 1,000 Lips bomb, which is of course not true, a lot of grenades, but just to make it easy, to make it a bit more clear. Yeah. So you've got 13,500,000 something. So within 8 years, that's the amount of UXO which has been notified to the government as being cleared or found or whatever. There's a filter in it as well. Yeah. So this is 1,600 tons per year. If we proceed like this, we need 951 years to come to the 1.6 million tons. I mean, it's clear that's not working. Yeah. So what are we talking about? We are talking about efficiency, and we talk about payment or market in the end, yeah? Because this is not a perspective. What we've learned from former presentation, like from Jens, is we have one area with 6,000 tons. Yeah. So on the Minzener Oak project, we did within 10 hours 12 grenades into the basket. That means, let's say it's a ton a day. Yeah. A ton a day, 6,000 tons, 6,000 days. If we have a vessel in place, we pay about 50,000 euros operational costs per day, let's say 40,000 euros depending by the vessel. If you have a platform in place, the clearance platform, the so-called pilot, I would suppose you have about 100,000 euros operational costs per day. And so, I mean, I have a bit of a pragmatic point of view, yeah, because I have to cope with it, I work with it every day, I see the costs, I see the time, yeah. So what we really need is actually, we need to get the picture that UXO clearance for environmental protection is a market, yeah. So it's not just only paying for it, but if you build up an industry, you have jobs, you have innovation, you have new vessels built, so part of the money you invest will come back, of course, yeah. And it's not like paying years and years and years. There is nothing coming back. Of course, you will get something back. Yeah? People are paying taxes. People are paying this and that, and you're buying things. Yeah. And when I drove here, I stopped at a petrol station, and there was a newspaper from the Bild-Zeitung. It's, for those who don't know the Bild-Zeitung, it's a kind of newspaper. Yeah? And they say, what shall we protect first? Yeah? Shall we protect the environment or shall we protect the jobs? This is nonsense. This is the wrong question. You shouldn't ask the question this way. Yeah? You should ask the question, how will you create a market to get all partners in and to profit from the effort? Because you profit from the natural preservation or the clearing the UXO out of the water, but you also profit from new jobs, from new innovation, and so far, actually, the industry for UXO clearance has been alone. German companies have barely, I don't almost no company which got 1 million to do something, to bring up a new technology. So it was all paid by the companies itself. And if you need a new approach, if you need new technology, and if you talk about efficiency, actually it should be a cooperational thing. Yeah? So the government should take part of it and say, okay, let's have a budget of 50 million a year. Let's bring the companies in. Give them the safety to invest, give them the freedom to prove new equipment. And then there's the point where the army can join as well, because of course the army has not the resources, it had not the technology. But to be honest, I mean, looking at the countries where the army is doing the UXO clearance, they are not that innovative like the industry is. Yeah? To be so, I'm sorry about that, but it's partly, at least partly true. Yeah? So Germany has a certain role in this, yeah, and has a very good pole position at the moment because the industry is very innovative. And but the army could join. Yeah? I mean, imagine we have to clear 6,000 tons, 6,000 days, 6,000 days of good weather, for sure not. 6,000 days of kind of operational weather, yeah, might be, let's say 4,500 days, sorry, let's say 1,500 days of bad weather period, yeah? I mean, you need to count on those numbers, yeah? So it's all about innovation and how to focus on the issue of this huge task of 1.6 million. If it's 1.6 million, Jens said it's probably less, hooray, perfect, yeah, it's less. But it's still that much that it's a huge task which cannot be addressed by the industry alone, by the military alone, or by the science. It needs to be a common force, or it needs to be something, a joint venture of all parties involved on that market. Yeah. So what I foresee, just to give a bit of an outlook, I mean, we have invented that crawler system because, I mean, the last 2 or 3 years, because I've been discussing this internally and I made up my mind, okay, we have to address the dumping areas. So what do we need? We need a stable platform on the ground. We need to work with 2 knots. We need to work without visibility. And so what do we need? So now we had a project with 1 crawler. 1 crawler is not enough. Yeah? So we need 3 crawlers. We need a platform. We need 3 crawlers. And we need humans. We need specialists on board. And this is another point. Yeah? If you want to address the UXO clearance of dumping areas, just a second or half a minute more. If you want to address that, you need to build up the specialists. You know, to be honest, there's only a handful of specialists on the German market which are able to do the job, because every single target has to be get rid of the sand, identification, and identification is a process which cannot be at the moment done automatically or by intelligence, artificial intelligence. So a specialist has to look and he says, it's fused, it's not fused, it's safe to lift it up, it's safe to transport to the KBD on shore. So this is actually the point. So if we need to address these dumping areas, we need specialists. And specialists we need to support the Kampfmittelräumdienst on land. We need to support the schools, yeah, which are bring up the paragraph 20 guys, yeah, because this is something which is not just somewhere in the scientific universe. It comes down to the persons who have to do the job in the end. Yeah? So support the schools, bring up the paragraph 20 specialists and start this process just now, because otherwise our EOD is getting older and older. Yeah? They are leaving the market, so the EOD specialists are not coming from the market in that amount. We need them. Yeah? I mean, if 5 people coming up, 5 specialists today, I would say, hey, welcome, just come in. We don't have them. So from the practical side, I'm happy to invite you for the presentation tomorrow about Minz and Oak, and that's it from my side so far. Thank you very much.
So thanks a lot. My name is Krabbenhöft. I'm coming from thyssenkrupp Marine Systems and coming from the industry. I, of course, think like somebody who's coming from the industry, and what we did in the first step was we are making a progress diagram, a process diagram. Oh, there you see the slide. I thought it was coming there. Sorry, it was my mistake. Okay, so if we start here with the process diagram, we have 10 steps where we are looking at. And a lot of the sections here have dealt with data collection. Of course, it's we have to start with the data collection with regard to all of the UXOs. And if we want to look at the UXOs, we have to make data collection, make the data evaluation, and make the diagnostics. And then it was the next step we were looking at. It was how do we get the UXOs from the bottom of the sea to the surface. And when we started with this, of course, it is we were just focusing on the UXOs which are safe for transport. And it's exactly what you just said. It's we need the exports from the bomb disposal unit. It's the Kampfmittelräumdienst, and of course we need their expertise. And I think we have heard a lot of ways now how to gain the data looking at the process steps 1, 2, and 3. So as we have a lot of UXOs on the ground of the sea, it was our decision then just to look at the UXOs which are quite easy to get, because there is a lot of UXOs. Why should we waste time with the difficult UXOs, especially in the dumping areas? So that was the reason why we have here in this process diagram yes or no. Of course, we try to look at the UXOs which are ready to transport or which are safe to transport. Then we have come to process step number 5, which is we wanted to take the UXO on a jig to handle the UXOs, because we've seen at some of the pictures here in the presentations over the day, there were really interesting ways how to do lashing with the UXOs and to take them on the ground. So we wanted to have an approach how to put an UXO on a jig which can be used during the whole process until the disassembling and cutting of the UXO. So then we come to process step number 6. So we would bring the UXO to the surface. We come to the steps number 7 and 8, where we do the disassembling and the cutting of the UXO. And then we start with the incineration process and the recycling of the material. And when we were sitting together the first times in our project team, we were discussing all this. And at the end of the day, it was the vision, okay, how could we do this large process into one platform, or how could we do it that it could be one process who doesn't have to stop. And this was something we were thinking of, and starting point was Atlas Elektronik. And Atlas Elektronik is one of the daughters of thyssenkrupp Marine Systems, and Atlas Elektronik had an R&D project where they were looking and scanning the ground of the sea, and they had UXOs on hand. And for example, Captain Eliassen, when he is going out with the Minesweepers, he's got Atlas Elektronik on board as well, and the sensors. So we thought that we have a lot of technique on board in our house that was from Atlas Elektronik, the mine countermeasure systems. Of course, it was from thyssenkrupp Marine System, the submarine technology. It was the surface technology coming from also tkMS, also with the system integration abilities. And we have within the thyssenkrupp AG, thyssenkrupp in Essen, we have a section called thyssenkrupp Automotive, where thyssenkrupp is doing process technology. And there we are coming back to the process diagram. And at the end of the day, we were facing a solution where we think that it's a good approach, that we have 2 platforms in place, one salvaging platform and one disposal platform. And these 2 platforms, you can see them here. They are, so at least the disposal platform has no propulsion. It is a 4-point mooring system, which could be then moored over the top of a dumping area. And then we would start the process, which I just have explained to you in the beginning. And this process we would start here with the platform where we do the salvaging. And of course, it is possible also in this area of process diagram that we look for other solutions. For example, the crawler just mentioned by Mr. Guldin could also be a possibility here to bring the UXOs into the jig. The idea of the jig was that we want to have the jig during the whole process now until the cutting of the UXOs later on the surface. And that's the reason why we have these single UXOs here on one of these special jigs. We have also designed a kind of roof around of caging around the UXO. So if they are leaking or if they are losing some parts, we could at least take them also to the surface. The idea then is, because we have here 2 process steps, where's a nice interface, to use these jigs to store, first of all, the UXOs, which are on the jig on the sea ground, so that they can wait until their slot for disposal comes. And then afterwards, we have the interface between the 2 platforms that we go from the salvaging platform or from the crawler system, we go to the platform for the disposal. So, and that's hopefully coming next, yes. Here you can see the jig where we grab the jig and to surface the UXOs, which are coming up then to the surface. And here you can see the platform. The platform on the right-hand side has got chambers where we delaborate, where we take out the UXOs. Here you can see the jig again, where we have the robot technique from thyssenkrupp and where we cut the UXOs into different halves. And then we have small parts here, which are maximum 8 kilograms. And these 8 kilograms we put then later on in this rolling area, and we bring it to the incination process. These chambers are especially designed in a form that they are explosive proof. So, of course, as we have a vast variety of UXOs, we have to look in which dimension we do the design of these chambers. But at least we have a roof on top, and then as they are remotely controlled and remotely driven, it is possible that in the event of an effect that they would withstand the pressure and would not cause any harm to the platform itself. So going to the next working step, we have here a rolling system where we bring the small UXO parts into the incination process, which you can see now in the middle. And afterwards, we have the metal and the filters, which are then left over, and hopefully we have the process ended here. So I was very pleased when I saw that the salvaging platform on your slides, and we think that this could be an industrial approach for bringing UXOs from the sea, from the bottom of the sea, and later on to the disposal process. And that's what we did. So our idea was, and I've already mentioned it, that of course we tried, first of all, that we look at the UXOs which are quite easy for us to access. And what was also important for us is that we use commercial off-the-shelf technology, because we don't want it to have some very big inventions, because it's also, like Mr. Guldin said, that it's for us also difficult to get R&D funding, and that was the reason why we thought it is possible to step on commercial off-the-shelf products. The whole platform is designed in a form that, of course, it can be moved also through Kiel Canal, so it can be also used in the area of the Baltic Sea and in the area of the Northern Sea. And there are a few options how we generate the energy on board. The easiest way would be doing it via a diesel generator set, but of course we could also imagine to step here on green energy. And if you want to look further into the different steps, we also have some examples here, which I put at least here on the backup slides. So I took some of the working process steps here in, and you can see that's, for example, what tkMS thought how the jig could be look like. And may I give you another slide here that we have the different chambers where we do the delaboration, and we have, of course, designed the delaboration chambers in this regard that they are designed to the needs which we are looking for. So, of course, if we have smaller objects in the working process, we don't need the whole safety for, let's say, 300 or 400 kilogram of TNT. So we could then design the chamber itself a little bit smaller, which also would improve the price. So what we wanted to show here is that in general it is that the possibility is that we have different areas here, and it is working with commercial off the shelf, and it's not totally invested in you. And what we are thinking is that bringing it all together, this could be a nice approach, or could be a clever approach for a solution for the whole problem. Thanks a lot.
Thanks to all of our panelists. Absolutely fascinating, because we're approaching this problem in this panel from different perspectives. We've got the scientific research part of it that's looking very much on detection and assessing the viability of remediation. That decision-making tool that your project is developing in Diamond 2, I find particularly fascinating. I'd like to get to learn more about that. We've heard a military perspective on this as well from the German Navy, and we've heard two spokespersons of the private sector, one working for a company, working in an industry that has been doing this day after day for a very long time and has very good understanding of the market. And we're seeing a major player in the industrial sector who's looking now into this very carefully and answering that call, it seems, from from governments to develop solutions on an industrial scale, as it were, as we heard from the state premier yesterday. So, very interesting perspective. I'm sure there are lots of questions. I already see that we've got some from our online audience. I want to get to those in just a second. But before I do, I just do want to follow up with a quick question to Jacek, sorry, about this decision-making tool that you're developing in Diamond 2, because this, I could imagine, would be very, very valuable to any, whether it's a commercial entity, whether it's a public entity that is considering, what do we, can we do something about this, and how much of a problem is it, and what are our options? Just wondering how advanced your tool is, and how much interest there is, and what applications you see for that evolving on the horizon. Is it still really just in an experimental study phase, or do you see uptake on this on the horizon?
Okay, so the tool itself is fully developed. So the final version was released in spring this year. And even before, the latest beta version was available since autumn. And we have experienced a lot of interest, both from public bodies like environmental agencies and also maritime administration, but also from the private companies like offshore companies. Because this tool has two aspects. It can substantiate your decision to remediate, but it also can substantiate your decision not to remediate. Sure. So if there is a munition which was detected, but it's not colliding with the investment, but it's somewhere in the study area, and the investor wants to show that this particular munition is not harmful for environment and is not a problem for the future investment, it can use this tool to prove it to a government in a scientific way. But at the same time, when people are making studies for a new investment, like a new pipeline, when they show the presence of munitions, then it's not only their paid experts who are saying that it's harmless, but you've got the second opinion, even by the governing body itself, who could check if this is a valid statement, that those munitions are harmless and need not to be remediated. Well, right now, we've got something like 300 registered users. This was the data from few months ago before holidays, so I do not know how much is it now. Jan Wendt probably would know that.
These are people who are using it now?
Yeah, some people are using it now, and so far I haven't seen a real decision made based on this, but it is definitely being used. And well, I hope that with this tool, we will be able to reduce the number of targets, because when you've got the dump site which has 6,000 tons, maybe if you remove 100 kilos of those munitions, you will already reduce a threat like about 1/3. So then you could go not on a large scale remediation with large facilities, but you can go on a small scale and just move from dump site to dump site, eliminating the high risk targets.
Sounds like it could be very useful, indeed. Commander Schmitt-Eliassen, you mentioned that your squadrons your ships, your crews, you are out there scanning 24/7 what's on the bottom. So if you're out there doing that all the time, you must have accumulated a rather significant database yourself. To what degree do you share that information with other entities?
Well, it's shared. It's centralized at our Navy headquarters, and it's shared with other nations and private or scientific institutions.
So you don't have some proprietary database.
You cannot download it from the internet, but okay. There are ways to get in contact.
Okay, and to both of you here, Jan and Dita, you both mentioned expertise as being a problem or being a challenge. where do you think that expertise, what kind of expertise are you talking about, and where do you see it coming from in the future?
Well, it's actually you need within the you need for the UXO clearance you need paragraph 20 personnel, yeah, which is actually trained EODs which have the license to work in Germany according to the explosive law, and those guys, they came in former time more or less from the army. So they've been trained by the armies as EODs, and nowadays the numbers of people coming out of the army is going down. Yeah? So it's less personnel which we can get into the private sector, and so we try to find personnel on the market, and we pay actually to send them to school, which takes a few months, yeah, which costs us usually about 40 to 50,000 euro per person, to get the person, men and women both, fortunately, meanwhile, into the situation that they can assess the risk of an UXO, which is always a single decision which cannot be just dropped. Yeah? So the decision if the UXO is safe for transport, yes or no, has to be done. And if it's safe for transport, you don't probably need it to bring it to a platform. You can sail it on shore. I mean, that's what we did. Yeah, if it's not safe for transport, yeah, you have to find other ways.
Well, I find this, this quite a gap, an interesting situation where there seems to be growing demand for expertise, yet the supply seems to not be growing, as far as I can tell. Jan Krabbenhöft, I know you're developing this platform. There's talk of maybe having it up ready for a pilot in about 2 years, is my understanding. Do you have the where do you get the expertise, and where do you see it coming in the future in order to fill this gap in expertise?
Yes, we've got the expertise also from the Navy or from the Army. And of course, it is right now. It's not really, as you said, it's not really a market. And normally the people, when they're coming out of the army, they were looking into design or into production in our case. Nowadays, as we have started with the product UXO, or the project UXO, we have a lot of people who would like to join the project because it's quite a fascinating project also. And of course, it is not just project management know-how needed, it is also G20 needed as well. So, and I think this is something where that's what I'm facing here, is there are a lot of people working on the problem, but the coordination itself is a little bit leaking.
Yeah, well, I hope the universities are out there listening to this, both here in Kiel and Rostock and Greifswald and wherever else there's competency centers being built up that might be able to address this. So perhaps they're listening in too. Let's open the floor for questions from the room and also from online. Let's start online.
Yeah, I'm prepared, but waiting for here we go. From the online community, if I go through the questions, I understand that this online community is well aware of, awake and well aware of all the systematic questions. And 2 questions are going to Jan Krabbenhöft. One is there a risk assessment for the vessels for the unlikely event that an UXO explodes when they are grabbed by the crawler? So it's a 2-step risk assessment.
Yes. First of all, of course, the platforms are designed for shock events, also like Navy ships. And the question is always, when will this happen? And we have also the chamber for delaboration, which is also for this shock event designed.
Yes, and the second question, well, you stated in your contribution that these platforms are not ordered yet because the government has not even provided the funds, but how much personnel is needed to get the 1 or 2 platforms up and running?
Well, we think with roughly 15 people in 3 sheets, and that should be enough for the platform itself. Maybe Mr. Guldin has got more experience with his salvaging platform, and maybe you could answer the question with the crawler.
So for the platform we've just had in Minsener-Oge, we had 20 people of personnel just for the checkup barge. We had 6 crawler pilots, 3 in each sheet. We had EOD specialists, 2 of them, for each shift, and we have geophysicists for positioning and data interpretation. Yeah, so at all we had on Minsener-Oge about 40 people on the platform to operate the system.
Yes. Same direction, and I think we need to come or to forward that to the presentation tomorrow. What is the expected annual capacity of these platforms? I think we do not know until we build the first one and tried it out.
Yes, of course, we are looking for a pilot in this regard, and I think this could be a good project. And of course, it is something then we should deal very open with the information we gain, because I think during such a project and such a project, we will gain a lot of information, which of course is, like we are seeing here, of interest for the whole community.
Final question from the online community so far. It goes to Jacek. Jacek, which environmental aspects and data will be considered to recommend the most environmentally friendly remediation measure in the future Diamond version? I will share the link to the project site and probably a short statement to that.
So, of course, the remediation starts on the bottom. So the benthic conditions will be critical. So both the biota population, which is in a given place, how sensitive they are, and of course the strength and magnitude of currents that could transport the leakage, and especially the source, which means the condition of munitions and the properties of sediments, meaning how contaminated they are and how easily they are to resuspend. So if you're working on sandy bottom, it's a lot safer than if you're working on muddy bottom, which is already contaminated by either munition constituents or with chemical warfare agents. So then you have to be very careful in selection of methods not to disturb the sediments or perform your activities in a perfect hydrodynamic condition when those resuspended sediments cannot spread. So that's why I think that the activity which was postulated to Baltic Sea Action Plan to HELCOM to actually perform environmental tests of existing technologies is really necessary. And this would be argument to the argument we are hearing nowadays that action is not as safe as no action. It's better to let them rot on the bottom because the remediation may be risky. So I'd say, first of all, we can minimize the risk by considering the factor I told about, and the other thing, we can actually go and test it.
Okay, thank you. Question from the audience.
Yeah, Sven Kuczynski. I have a question to Commander Schmitt-Eliassen. And I'm happy that the German Navy now considers more the environment in their daily work and the mine clearance. And my question is there a difference in nature conservation objectives you are focusing or you're looking at when you assist in German waters or when you are part of a NATO operation? And especially, or a special question, you mentioned that you are using methods or means available for scaring mammals off the site. Do you have new means available since the 2019 event in Fehmarnbelt when dead harbor porpoises were washed ashore?
I'm not sure, but right now we are, besides all the making a noise and an increasing level, which we did basically when I was a small sailor as well. I guess after that event, introduced a so-called seal scarer as basically the latest step or the last step of trying to scare mammals off. So I guess that is actually introduced after that event. Invited or asked for assistance by nations or federal states, and we follow that invitation with the means we have at hand. And well, in Germany, the Navy operates under the umbrella of the German Navy, basically. In other maneuvers, sometimes under the NATO umbrella, which is then another case. But also those activities I just briefly mentioned take place there.
But you need to follow the nature conservation law in other states, and if that's in the EU, that's EU law, the Habitats Directive, for instance. So it would be the same. You would do the same steps for animal security, either here or within the NATO frame. And if I may add another question, that is on the bubble curtain experiment you mentioned, whether you can drive your one-shot drone in that environment. Was that so successful that you still consider this as an option for the future?
Yeah, of course. As I stated, I need to train my crews basically on hot ordnance, and that is the greatest way of doing that while preventing damage to environment. So I hope we will be able to introduce such a installation for our training purposes.
Thank you.
Thank you. So we still have a little bit of time left. If there are questions, we do have something coming from online. I will get to that, but I'm just dying to ask this question myself, and it's one of the great privileges of being a moderator that we will get to that though. The question is this, and whoever wants to answer it, you can all give it a go if you wish. But what are the main obstacles at this point, in your view, to large scale? To scaling this up, to moving forward with that first big pilot project we keep hearing about, where is that going to be? There seems to be a demand for getting rid of the munitions as far as possible, assessing the viability of that, of course, developing techniques for doing it, developing a market also to respond to the environmental pressures, which is so far not being served to a large degree, it sounds like, given that pie chart that we saw from Dieter. What do you see as the main obstacles holding this back? What do you see as the main enablers that need to get into place to upscale the clearance of munitions in the sea? Who would like to give it a shot first?
Oh, well, from the technical point of view, I would say we are basically there. Yeah. I mean, it's quite ambitious to say so, yeah. But based on our experience on different projects in the last few years, yeah, I've seen what we've been able to do and what we've been able to develop. Yeah. So I would say as soon the government stands up and comes up and says, okay, we are now interested to start with the project. Let's say a smaller dumping area around the vessel. We would be able to start within 4 months, I would say. Joint forces on the market, experience, and the will to pay for it, we start within the 4 months.
Okay, so you're saying what's there, but what would you say is not there? The will, the money, the knowledge?
Yeah. Look, I mean, we had experience with the crawler at the moment. Yeah, I mean, one crawler is not enough. Yeah, so steering the crawler remotely from land, for example. That has not been possible 2 years ago. This is just, it's really technology which just appears at the market. Yeah, we are kind of on a border situation at the moment. Yeah, to have all these 5G data transfer or to have the ability for positioning and steering. Yeah, so I would say at the moment I do not see that much of a problem. Yeah, to be honest, from the technical side, we could on a lower scale we could start immediately. And very important, just a last one sentence. Yeah, you cannot just plan everything in advance. You have to start and you have to learn by the job. I mean, if we wouldn't have had the chance for the Minzener Oak job, we would have not been able to do the experience or to face the problems we've seen. And we've faced quite a lot of problems. Imagine the amount of problems we had to solve. Yeah? You have to start at a certain point and you have to work under the running wheel.
And sorry if I may, I'm absolutely with you. And you said the funding is missing because of the government. And I think this is one of the main problems, because which government we are talking about. And of course, if we're looking in Germany, that interest is, of course, through all the coastal countries within Germany, Schleswig-Holstein, wir haben Mecklenburg-Vorpommern und. And on the other hand, of course, it's the Minister of Transport who's responsible here for this area on the streets in the water. So, and I think this is quite a problem which has to be solved.
But it's like it's like I said, yeah. I mean, you know, if you only focus on the situation that the government has to pay for, yeah, that's the wrong situation. That's the wrong focus. They have to focus on the chances. They have to focus on the market, on innovation, on new jobs. I mean, look at the jobs which have been created within the wind energy. Yeah, I mean, if we would have said, we need new, we need green power supply. Yeah, so government has to pay for it. So that would have been the problem. So people have been focused on the market, on the chances, and innovation took place. Yeah, so there will be a feedback.
That would be the other way to phrase that question, of course, is how do you develop this market? You know, what do you see needing to go? Anyway, just so we don't neglect what's coming there from our audience, Klaus.
Yep, a very detailed question to Jacek, and I'm curious to hear the answer as well, but I really don't understand the question, so I will read very carefully. He's a professor, so that's fair. Jacek, how was the threat to military training in the Wracker model determined, and who was involved from military side?
Okay, so the Wracker model comes from Chalmers University of Technology in Sweden, and they've been basically surveying most the officers of the Swedish Royal Navy regarding the activities which happened during the military training in military training areas in Sweden. And basically it was the impact of those training activities on the wrecks there, because the original Wracker was designed for wrecks. And this includes, for example, the noise level at sea, so pressure waves. It includes some bottom activities like diving, also blasting in place or demolition of explosives nearby, or training charges. So this was this type of activities, and according to my knowledge and according to what I spoke with the people from Chalmers, they went again to those same military. It was a group of something like 20 plus officers, and asked them what would be the impact on munition, and also they recalculated, for example, the pressure waves and the bottom disturbance, how it would affect those munitions. So the entire Wracker is a bit survey-based, but we try to update it with the real scientific knowledge. So basically, in the input field of Wracker, it's like you are able only to give how many trainings per year are in this area. in this particular area. And I think the radius we have scheduled for this parameter is something like 30 miles. So if there is any military training within a radius of 30 miles, we assume there is a military training and it may have an impact.
Good. One more?
Yes, we have questions and statements within the chat. And as soon as Jan and Dieter do not insist, I would say that's sufficiently answered. The question is to what depths, water depths, these platforms are built for. And the answer within the chat is 20 meters is fair, up to 50 is possible, and more is not needed in this particular target area close to Schleswig-Holstein and Mecklenburg-Western Pomerania.
Good answer.
Okay, we just have a couple of minutes left. Is the gentleman, okay, I just didn't know if you wanted to ask a question. Did you? No? Okay, all right, fine. Okay, any more questions from within the audience on this topic? Okay, good. Any comments that any of you would like to add before I move on to the next program point? Just a reminder that tomorrow we will have sessions on both stakeholder roles and responsibilities, which this discussion is kind of pointing towards, as well as economic opportunities involved in this. So talking about how to build the market and how to upscale all of this to serve a variety of interests we'll be addressing as well.
Yes, so maybe just one comment regarding one of the reasons that it's not really pushed forward or is not pushed forward enough regarding the remediation of munitions. The threat is not real enough. Because we do not have time series, we do not have monitoring. As it was mentioned on this conference, we've got case studies. Case studies started and finished, and it just recognizes some particular problem and gives particular answer. And because we do not have time series, we cannot make a forecast. So if the people are asking us, is this presence of munition going to absolutely create a catastrophe on the Baltic Sea or not? We say, well, it may, but we do not know how probable it is. So until we are able to put a number to this value, how probable it is, maybe in percentage, then this element will be missing.
Final comment, I see Dieter wants to say just something briefly.
Yeah, I mean, at the moment everybody's looking on climate crisis, yeah, so, you know, the discussion is like, okay, what's the responsibility for Germany, for example, yeah, within that context, yeah, and we are responsible, yeah, but looking at the UXO, yeah, and the dumping areas, we are definitely responsible for that, yeah, so there is an obligation for further generations to do as much as we can in the time frame which is given, yeah, because it's not, I mean, this is not a discussion which can be postponed to another generation. It's on us to react on the situation because time is running, and otherwise we're going to lose the war a second time. So, and actually, it's not, you know, it's not, there is only one drop necessary to create a disaster. It's not the whole barrel, yeah. So if there is one drop too much as a kind of problem in the Baltic Sea or the North Sea, a disaster can arise from that. Yeah? So it's like, you know, the Dorsch has a problem in the Baltic Sea. Yeah? So the amount of fishes is going down. We're creating a lot of noise. We're creating a lot of stress. So this is all adding up. Yeah? Of course, if you say, okay, what's the chemical impact of ammunition at the moment? Yeah? You could say, it's reasonable, it's measurable, but it's probably not that creating that much of a problem, but that's actually not the issue. The issue is that we're adding up from many, many different sides, small problems, and we should not adding up more problems. We should start with getting the stuff out.
Great note.
Yeah.
Yeah.